from the quiz. Okay, so who's got one? Alan?
Problem 1 on.
What's the question say?
It's the color one, like the 50 students in a group.
Okay, yep. All right. So we have 58 students in a group. The box has 58 people in it. And 27 of them like blue, and 27 of them like yellow, and 26 of them like green. So we've got a blue, a yellow, and a green circle. And I told you that 5 like all of them, right?
Yeah.
And we have 2 like only blue, or no, 12 like only blue, 11 like only yellow, and 10 like only green. So that was the given information. Now, you may have had a different quiz than this, but did you have to do basically the same thing with just with different numbers? Yep, so pay attention if you missed it. Okay, so then what? What happens now?
Put in the variables.
Yeah, now I gotta worry about my totals. I gotta start adding up my totals. So I'll stick some variables in there. And you can put in whatever variables you want. I'm going to go ahead and do what I normally do, and that's X, Y, and Z. But if you put in different variables, or if you put them in a different order, your equations will look different, but your answers will be exactly the same. It doesn't matter if you call this X, Y, or Z. This section is going to have the same value in the end. All right, so all the sections in the B-ball have to add up to 27. So all 4 sections, there they are, all added up have to be 27. All of the sections in the Y-ball have to add up to be 27. And then all the ones in the G-ball add up to be 26. All right, now I was talking. Did I get all that right? Now, what do I have to do next? Not have to, but probably should. What should I do next? Simplify the equations to make them easier to work with. You can solve this system, but it's easier if you simplify the equation. So that's 17, right? When I move that over, that means X plus Y has to be 10. This is 16, so X plus Z has to be 11. And that's 15, so Y plus Z is also 11? Is that right? Now what? Pick a couple of them. We have been using the first 2, you don't have to, but do it. And eliminate X. That's the only thing you can eliminate because if you use these 2 equations, because it's the only thing that's in common. So I'll multiply 2 by negative. And this then produces a new equation, y minus z equals -1. Right? Which is going to get combined with y plus z equals 11, my third equation that I haven't used yet. Well, now I can add those together. So 2y equals 10, which means y equals 5. And the minute you put a 5 there, everything else is automatic. Because what do we know about this circle? Has to add up to 27. Well, what do you have right here? Right here you have 22, so this also has to be 5, doesn't it? And then this also has to add up to 27, and you've got 21, so is that 6? And then to check myself, this one has to add up to 26, does it? Yep. So there it is. All the pieces filled in. Okay, Ollie, you got that? Okay. So now we can answer the questions. And a couple of you, I think just got going too fast and didn't quite read the question. It says, find the probability of choosing one student from the group who likes yellow and green only. So, yellow and green only would be right here. But it's a probability question. So it's 6 over 58, which is 3 over 29. So that's the answer. Now, if you said 6, you are on the right track. You just didn't make it probability. If you said something else, then we're on the wrong track. All right, what's the probability that someone likes none of these? Well, that's out here, right? Those people are out here, and I don't know what that is. So how do I figure out what's out here? I add them all up. So what is all that? Someone add all that up for me. 27, 54. What is it? 37 and 17, 54. So did you get 4 people out here? So then the probability of picking someone who doesn't like any of those colors would be 4 58s, which is 2 29s. Okay? All right, who's got a 2 problem to do? Alana?
The Mr. Rhodes quiz. There are 28 students in Mr. Rhodes' class.
Mr. Rhodes' class?
Yes.
All right, so we have, and again, everybody had a problem like this. So if you missed it, pay attention. Here is the class. There are 28 students in the class. 15 love supply, 16 love demand, and 6 don't like either one. So I'm just going to put them right there. They don't like either one. So we've got our supply, our demand, and there's 6 kids out here that don't care for it at all. Okay, and then the question is how many like only supply? So I'm going to try to figure out what this number is right here. This is only supply right here. All right, so here's what you're thinking. There are 28 students, but 6 of them are not in the balls, right? So that means, I think it was voting. 6 of them aren't voting. So 22 kids are represented in this area, right? There's 22 kids in that area. So 22 students are going to vote. They voted. Here's what the vote came out to be. Now, how many votes are up here? How many is that? 31. 31 votes were cast by 22 people. So some of them voted twice, right? How many too many is 31? 31 is too many. How many too many? 9. So 9 people voted twice. 9 people got counted twice. Now the whole S circle is 15. What does this have to be? 6. That actually is the answer, but let's go ahead and do this one. The whole D circle is 16, so that has to be 7. The question was, how many like only supply? These are the 6 that like only supply. That was not a probability question, that was how many, so it's 6. If it had been probability, you would put it over 28. Those are guaranteed test questions, folks. So if you haven't yet figured out what to do, you better be getting in here, right? And please don't count on fluxes next week, because I think there's one, maybe, next week, because of I-step testing. So now what I want to do is practice for the next quiz. Mrs. Ford, all these quizzes are killing me. They should be better than. Nope, it won't be next week, I'm pretty sure of that. Yeah.
Can you pass the paper down, buddy? Thank you.
All right, did everybody get one? I'm sorry, they're kind of light. I don't know. I don't know. I don't know. Anyway, here we go. So we talked about this stuff. I don't know if it was the last class or the one before that. We're going to shade in regions of the Venn diagram. So your actual quiz will only have 2 of these and 1 of these. So this practice is double what the real quiz is, okay? Just so you get some extra practice. All right, so we're going to shade in our P's and Q's. So the first one is this. Who remembers what that means?
Intersect.
Intersect. Chuck, which means what?
Everything in between.
Where they overlap each other, right? Intersect means where they overlap each other. So basically, I'm just shading the football. Easy, easy. Now, what does this mean?
Just Q. Just Q.
Not Q. Remember, this little mark means not. So, not Q. So that means you're going to shade everything in the whole picture that is not Q. So that means I'm going to shade everything except this circle right here. This circle is going to be open. Everything else in the entire picture is going to be shaded in. You'll do a better job of shading. It makes my boards too messy, so I don't want to overdo the marker, but you understand what I'm shading there, right? Everything except the Q circle. What's this one mean? The union, which means what?
Just the circle.
Everything that's in the circles. Yeah, just what's in the circles, but this is everything that's in P or Q or both. So everything that's in the circles. So if P is people that like tea, and Q is people that like coffee, we're shading everybody that likes coffee or tea. Right? And then the last one, do not be confused. Do not be confused. Didn't we just shade that?
Yes,
Yeah, so you don't
Right? So that's everything in the circles, right?
everything outside.
So this is gonna be everything not in the circles. So everything not in the circles, so that would be everything outside. So in my tea coffee example, these were all the people that like tea or coffee. These are the people that don't like tea and coffee. Right? Tea or coffee, either one. And anybody have a question about that? I'm not saying that these are the exact questions that are going to be asked, but we kind of hit all the main ideas there. Okay? All right. The probability of Gavin being on time on late start days is 28%. And Gavin, I'm sorry, I should be picking on Marcella since she now is 3 for 3 this week.
Usually are that guy.
The probability of Gavin being on time on late start days is 28%. The probability he's on time on regular start days is 64%. We have a late start 2/7 of the days. What's the probability that he won't be on time? All right. So this is one of those two-stage tree diagram type problems. Okay? Just like, remember the example we did yesterday? And it was meatloaf and potatoes or something,
Yeah.
remember that? So this is kind of the same thing. So what does it all hinge on? What's the starting point of the problem?
Late start.
Late start or not, right? So we have,
LS.
late start and regular start. Okay? So, late start, be careful, is 2/7 of the days. So isn't the probability of a late start 2/7? And then a regular start would have to be 5/7, yeah. Now, he's either going to be, how did I say it, on time? So he's either gonna be on time or late. It's gonna be on time or late. Now, on a late start day, the probability of his being on time is 28%. Would you agree with that?
0.28.
Yep, 0.28, which means him being late will be 0.72. On a regular start day, he's on time 64%. And that means he's late 36%. So everybody, does the tree make sense to everyone? Okay, what is the probability that he won't be on time? So won't be on time means we're looking for late, right? So who remembers what we do now? What do we do now?
5/7 times. Well, for the top, you can do 2/7 times 7/2.
Exactly, would you do that for me?
Yeah.
2/7 times 0.72. Hey, let's engage, people. Get your calculators out. Let's go, let's go. We got a quiz tomorrow. We want to do well on it.
You multiply 2/7 times 0.28.
We multiply 2/7 times 0.72,
Or, 0.72.
because we want to be late.
0.205, so 20.5%.
So let's leave it as a decimal, 0.205.
Yeah.
Okay, now we do say round to the 10,000th. Is that O on the end of that, 0 on the end of that?
That's a 6 or a 7.
Here?
Yeah.
So 0.2057?
Yeah.
Okay. Now, so that's that way of being late, but we also have this way of being late. So we're gonna multiply 5/7 times 0.36,
Yeah. 0.2571.
2571. And then what do we do to get the final answer to the problem? Add those together. So what do we get when we add those together?
0.45 or 4628.
And that's the answer. That's what goes in the answer blank right there.
Wait, those two?
This right here.
Oh, just that?
That goes in the answer blank. That's the probability of being late. Now, I'm not sure how to say this without making it more confusing. I don't want it to be confusing. But if you are ever struggling with like what order to put these things in, like we started with regular start, late start, and then we went to tardy on time. If you're ever struggling with that, figuring out what order they are, remember that whatever the question is asking has to be the end of the problem. Because it says, what is the probability he'll be late? That has to be on the end of the problem. You see what I'm saying? That has to come second. All right. The probability of Emerson paying attention in a morning class is 56%. The probability that she pays attention in the afternoon is 73%. If our class is in the mornings 55% of the time, what is the probability that Emerson will pay attention? Okay, so what do I start with? Morning or afternoon. So I have a morning class and I have an afternoon class. What are the probabilities of morning and afternoon?
It's 56%.
Morning is 55, which means afternoon is 45? And then she's either gonna pay attention or not pay attention, right? All right, so in the morning, her paying attention probability is 0.56. Everybody understand why I put that 0.56 there? And then this one would be 0.44. And in the afternoon, her attention is 73. So her not attention would be 27. Now what are we looking for? The probability that she'll pay attention. So we want this branch and this branch this time. Okay, so why don't you all type that in and see if you can come up with the right answer. I'll do it too. And I'm sure we're all going to get exactly the right answer. Okay with that? 6365, 0.6365. Okay? All right. While I am getting the attendance taken, would you please get your books out or pull them up on your iPad? We're going to do a couple of problems in the book today. Really need to be able to see the problems, so if you did not bring your book, don't have a book, find somebody that does and screenshot it. Because you need to be able to see the problem in order to do the problem.
This is cool.
Yep.
Is the restroom?
Emergency?
Yeah.
Hurry up.
Hey.
My gosh, and I is that again, that little girl? Perfect, thank you. All right, Gavin, your book's up here. All right, so I am looking on page 728 of our textbook. So you all should have it up on your iPad by now.
What page?
728. 728. All right, everybody looking at it? Okay, I want you to look at problem 9. Problem 9 on page 728. Here's the deal. This guy has done some data. With his gerbil, and he's come up with this probability distribution. So we're on page 728. We're looking at problem number 9. We're going to look at several problems on this page. Now the question is, okay, so what this means is 25% of the time the gerbil was in compartment A, and 20% of the time it was in B, and so on. Now, the question is this a valid probability distribution? Is this valid? I'd like you to look at it for a minute and see if you can answer that question. I'll tell you it's not. What's wrong with it, Chuck?
Doesn't go over 100.
Exactly. To be a valid probability distribution, we know that the probabilities have to add up to 100. It's just like the tree diagrams we were doing. If you've got 4 outcomes over here, on time, not on time, on time, not on time, those have to add up to 100. That's the total. What do these add up to? Yeah, too much. So the question is this a valid probability distribution? And the answer is no. Okay, now they give you in problem number 11 to 16, that's our next job. We're looking at 11 to 16, and they all use a valid distribution where we've got brown and red and yellow and green and orange and tan M&Ms, okay? Somebody has taken a bag of M&Ms and figured out that 30% of the M&Ms are, what's B stand for, brown? 20% are red, 20% are yellow, and so on. Notice these add up to 1. This is a valid distribution. Okay, question number 11 says, you're gonna reach in and grab an M&M, one M&M. This is your bag of M&Ms. 30% of them are brown, 20% of them are red, and so on. We're gonna reach in and grab one out. What's the probability that it will be brown or tan? Brown or tan? What's your answer? Brown or tan? Point what? Oh, Anna, say it.
Oh, I didn't.
Oh. What? 0.4. That's exactly right, Marcella. Brown or tan. We talked about this yesterday. When a mathematician uses the word or, we add. It's this or this. So what's the total? So it's 0.3 or 0.1. So we add those. 0.4. What's the probability we'll get a red one? 0.2. Right there in the chart. 0.2. There's red. 0.2. What's the probability? Oh wait, that was 13. Sorry, I'm going out of order. That was 13. 12. 12 is red, green, or orange. Red, green, or orange. What's the probability of red, green, or orange? Let's see, red,
0.4.
green, and orange, wouldn't that be 0.4? Red, green, orange. And then 14 says not red. So what's the probability if you reach in and grab an M&M out of this bag that it will not be red? I heard it. 0.8. Because the probability of red is 0.2. So not red would be everything else. 0.8. And then 15. Neither orange nor yellow. So you're going to reach in and grab one, but it can't be orange or yellow. What are you saying? 0.7? You're right. Because orange or yellow would be 0.3. So not orange or yellow is the other 0.7. And finally, number 16, neither brown nor tan. Neither brown nor tan. 0.6. Everybody okay with that? Neither brown nor tan? Okay, now, the very next set of problems involves a different bag of candy. Same idea. So in this bag of candy, we've got brown, red, yellow, green, orange. Brown, red, yellow, green, orange. That's it. And it's 0.3, 0.2, 0.2, 0.2, 0.1. Okay? So now we're using this bag of candy. Now the difference is we have two of these bags. So the bags are identical. This is the proportion of each color, but I have two of them. And I'm going to reach in and grab one out of each bag. Okay, so I'm going to reach into this bag and grab one, and then reach into an identical bag and grab one. So what's the probability both are brown? So what's the probability that I will get a brown and a brown? No. It's not brown or brown. It's brown and brown.
It's not very good odds.
0.3, because that's brown, times 0.3. Remember, when you are doing two things, and when it's this and this, we multiply. Remember your branches were a late start and you're on time, so we multiply. This is, if I were doing a tree diagram, this would be brown and brown. So I multiply, and it's 0.09. So somebody said the odds aren't very good, and you're right. There's a 9% probability of getting brown and brown. How about both are orange? Well, both are orange would be 0.1 times 0.1. So 0.01. You got a calculator, type it in. One is red and the other is green. One is red and the other is green. So one red and one green. What do you think? This one's tricky because one red, think of your tree diagram. Could the branch be red and then green? But couldn't it also be green and then red? So we have to do two problems here. So red, green, so in that order, red, green would be 0.2 times 0.2? Or 0.04? Red, green. Now what would green, red look like? like? Same thing? So green red would be 0.2 times 0.2 or 0.04. And since it could be this or this, what am I going to do with those two numbers? Add them. So the answer to the question is 0.08. That's going to trick some of you. That's going to catch you. You really got to think that getting a red one and a green one means you could do it in either order. This is problem 20. The first is brown and the second is yellow. The first is brown and the second is yellow. .06. That's right. 0.3 times 0.2. Now, do I need to worry about going in the other order? No, because it specifically says the first one's brown, the second one's yellow. Done. Neither is yellow. Grab one out, grab another one out. Neither is yellow. All right, what's the probability I won't get a yellow one? On this bag right here, no yellow.
0.06.01.
Just pick one out. What's the probability it won't be yellow?
0.012.
Guys,
0.8.
0.8. Thank you. What's the probability of being yellow? 0.2. So the probability you're not yellow is 0.8. So I want both of them to not be yellow. So I will multiply 0.8 times 0.8. If there's a 20% chance you're yellow, then there's an 80% chance you're not yellow. One more. The first is not red, and the second is not orange. The first one is not red. Okay, so let's deal with that. Not red would be what? What's your probability of not red? 0.8. What's your probability of not orange? 0.9. So the answer to the question is 0.8 times 0.9. Three big ideas there, and we've talked about all of them before, but let's go through them again. If you are doing two things at the same time, X and Y, you multiply the probabilities. If you are doing them one or the other, X or Y, then you add the probabilities. And if the chart gives you the probability of something, so for example, the probability of brown is 0.3, then you can always calculate the probability of not brown by subtracting from 1. So if the probability of brown is 0.3, then the probability of not brown is 0.7, right? If the probability of green is 0.2, then not green would be 0.8. Good? Okay, a couple more on this page and then we'll be done with our book. Let's look at number 27. 27 is what you already know how to do, it's just written differently. So I want to make sure it makes sense to you. So 27 says we have a sample space, S, and we got A and B inside the sample space, which is your Venn diagram. The probability of A is 0.6, the probability of B is 0.5, and the probability of A and B is 0.3. It says draw a Venn diagram. Yeah, this is math, like, what do I wanna say? It's written using math terms, okay? Symbols, math symbols. But it's what you already know. This means the whole A ball is 0.6. The whole B ball is 0.5. And what does this mean? What is this? Where is this in my Venn diagram? That's the football in the middle. That's PN or ANB. So this is 0.3. But now wait, the whole A circle is 0.6. So what is this part? 0.3. And what is this part now? If the whole
0.2.
B circle, that's 0.2. Now these are probabilities. So how much do we have represented? We have 30% and 30% and 20%. So that's 80%?
Yeah.
Okay, but wait, there's more, right?
Oh, it's 0.2
There's
on the
another
outside.
20% that's not in the circles.
Yeah.
See how this is exactly like what you've been doing? It's just in terms of probabilities. So now we can answer the questions. Everybody's watching the clock. Chill out. Oh, shoot. Shoot. It isn't. Darn it. All right. Thought we had 5 more minutes. All right, so we'll pick up here. Shoot. When will I pick up here with you people?